Good afternoon, everyone. We'll get started. So first, we'll define what is service mesh definition pretty clearly, so that we'll able to understand what's the problem you're facing and what's the solution for it, right? Because the moment you search for service mesh, right, there will be a lot of definition of what is service mesh. So I wanted to set the stage very clear and what we're talking about. What is a service mesh? Okay. So it all started from here, right? So we had a monolith where everything was together, user interface, business logic, data access layer and database, everything was here. And then due to a lot of reasons, and we wanted to scale up and we wanted to do a lot of teams, we wanted to build it parallelly, all those things. And then we went to this way of doing it where you split every business logic into small business logic and then make this thing happen, right? And a lot of teams build it. With this, there are quite a few challenges which needs to be addressed. In this previous one, right, everything is happening in a single, so everything is happening in the single application layer boundary, and you don't have to worry about how much bandwidth, you don't have to worry about all these things. But the moment you implement microservices, right, you have to consider all these things, right? How I'm going to route it, because everything is going to happen through the network interface, and how I'm going to do a routing, what's the traffic control, if my packet fails or if a HTTP request fails, what's the resilience for it, and then how about the security, can somebody intercept the traffic and read about what I'm talking to the other service, right? And then observability, right, how many times I'm calling it, how many times it failed, what is the latency, all those things comes into the picture, right? And what we end up doing is we get all this non-functional requirement. The moment we get into the steps into stones of microservice architecture, you get into this where you need to do an authentication, authorization, then transport security, circuit breaker to safeguard you from cascading effect, and then rate limiting, and then release management, retries, whatnot, right? You have to do a lot of things on top of that. What I meant by that is, right, let's assume this is your service A code and this is your service C or whatever, right? And you have all this non-functional requirement, and what you'll end up doing is you'll end up implementing that particular layer in your code, right? So to authentication here, and then you need to do something here. On TLS you'll implement something here, and you'll implement something here, right? Circuit breaker you do something here, rate limiting you do something here, release management you do something here. So you'll end up adding more and more code to a service, and you will be end up writing for these things. And this is not the end of this, right? There could be much more requirement will be there, and you will end up adding more code here. And think of it, right? In the microservices, you also we encourage everybody engages to write in different language, right? So Ruby, Python, Java, Golang, Rust, or Haskell, whatever programming language. Then you have to end up implementing these things in all the languages. There's no way out, right? And that's not the end to it, right? So then what will happen is, this is where we'll end up getting into it, right? Where you will have these many versions of these many packages out, and these many services will be using that particular version, and if you want to roll out a particular version, and we are doomed, right? You need to go and see which particular version has it, or which particular person uses it, upgrade it, you have to do all these things. Okay. What is the way out, right? So instead of these things being part of the code, right, why not that be out of process? Why it should be part of your application same code, and why it can't be out of process? And most of the requirement whatever you're seeing, right, it can be done by a proxy. Whatever feature you're talking about, right, circuit breaker, rate limiting, list management, retry, authentication, authorization, all those things can be done by a proxy. So introduce all those things and then make it as a proxy, and there born the service mesh, right? So in front of your service you put a proxy, and then you take care of everything, and then you join everything to the service mesh, and you get all these nice features, right? So one common way of implementing this Onvo is very popular with Istio and other stuff, where you put a service and you put a sidecar next to it, and then all your requirement for whatever we saw earlier, right, it's all taken away from you, and it's been taken care by the service mesh implementation, right? So far so good, right? Then what is the problem? Why is it we are talking about future, and what is it, right? I quickly talk about the first problem. What is currently now is problem of plenty, right? What is problem of plenty? You have linked you have Istio, you have HashiCorp console, you have AWS App Mesh, you have Nginx, you have Open Service Mesh. I actually didn't put lot more, there's a lot more, right? And let's say or day one, I actually or one of my friend suggested something, or I attended a talk and then it looked very fancy, and then I actually bought that idea, and then actually I went with something like Linkerd or Istio, whatever, right? Now after you adopted that, you are facing a lot of challenges, or it's a wrong fit for your application kind of things, right? For an example, if you go with Istio, right, that brings in its own lot of components, and it will, you need to give a lot of CPU memory, all those things are there, right? You want to switch to a lighter one, which is Linkerd, but you cannot do now because you're already married to Istio, and if you want to move to Linkerd, you cannot do that. You cannot do that switch that easily, right? You have to rewrite all the things what you wrote in Istio, and you need to find whether there's a match in this Linkerd world or any other service mesh world. You need to see whether there's a exact match is there, right? Otherwise you have to live with it, because the decision once you made, you cannot revert it. So what is the solution for it, right? So Microsoft and a few other company put together, they came up with something called service mesh interface. So this is something equivalent to your SNI storage network interface, storage interface in Kubernetes, right? This is something similar to that, which is service mesh interface, where all these service mesh implementation others to the service mesh interface. You write all the traffic policy, traffic telemetry, traffic management in SMI. This can be any of that. So it will get converted, and you can actually use any one of these service mesh underneath. You don't have to write in these terms, but you can write it in the service mesh interface world, and then you will able to implement this. Okay.
Hey, good afternoon, Art. So I'm audible. Okay. So we'll go to the next problem that we are going to talk about. As multi-cluster is not something new, but it is something that we are seeing most of the companies now moving to. So if there is a small cluster with small organization, small cluster, you have like say a 10 node, 20 node cluster, this problem won't even come to you. But if you're say scaling up and you want to segregate your clusters, for some reason you want to run particular services in one cluster and few set of other services in another cluster, right? But you still want to have all the advantages that you're getting by implementing service mesh across these clusters, right? So how to do that? So right now most of the famous service mesh implementations have already solved this problem, and it's something that you can right now use. So this is taken from Linkerd actually. So where you can have something like a cluster mesh setup, or a cross cluster multi-cluster setup, a multi-cluster mesh setup. So you would retain all the benefits of service mesh. You basically you can have a single source of trust. You can while doing that, you can also segregate the failure. So if service mesh in one of the cluster fails, it won't impact the other cluster, so it will still continue to run, right? So this is already there. It's already there in Istio. Istio has several other models of implementing it. Linkerd gives this model, right?
Okay. So the next problem is extension, right? What I mean by extension is there are use cases. Even though we brought in proxies which can actually do all these things, but there are still few cases which still proxies cannot do it, right? For example, this is one thing, right? Response transformer. Let's say you are returning JSON, and suddenly you want to return XML, or you want to return some kind of some other format if you want to do it, right? You still have to code for this, right? And how about CORS implementation? If you want to restrict some of the based on the CORS, if you want to restrict, and if you want to restrict based on the request size limiting, open agent policy, or if you want to do an IP restriction, all those things if you want to do, you cannot, you have to write a piece of code now, right? Even though we said that service mesh is there, it can take all those things, but for all these things, I don't think service mesh actually solved it for you, right? It is possible in Envoy. Actually, you can write some kind of an extension in Envoy, but you have to write it in C++, right? And so that, and you have to bake it inside Envoy, and then take that up and then put it along with your Envoy, and Envoy can actually do it. This is pretty much there in all the things, right? Nginx has something called Lua. ambassador, you can do it, everybody you can do it, right? But if you think of it, right, if you want to change this proxy, then you have to change the programming language, right? This is C, C++, and for Nginx you have to write in Lua or something, you have to write in something else, right? So instead, what is happening now is there is WebAssembly, right? And people are taking WebAssembly, and then you can put it as a VM, and that takes care of all this running your thing, right? So you write the code in WebAssembly and then put it here, and then irrespective of these things changes, right? These things can still be the same, and you don't have to write it in C, C++, all those things, and you can leverage the WebAssembly for this. And there's already support for Istio, and you can write it in WebAssembly. You can put your own filters, which is written in WebAssembly.
Yeah. So this is something that we wanted to talk more about, and this is something that Bharini gave a heads up in the keynote in the trends talk. Sorry. So this is the model that you see right now in most of the implementations of service mesh, where we have a sidecar model, and all those applications that you're launching in your cluster have a sidecar container. It looks okay when you have a moderate level cluster, right? When you're scaling up, just imagine the number of sidecars that you would be injecting. So it's essentially same number as your applications, right? And if you have, let's say, 30 pods per node, you again have 30 proxies per node, right? I think if you, at the end of it, if you have scaled enough, you will realize that you're spending more resource and compute on these proxies than your actual application, right? So that is a problem that we see, and a bit of networking. So basically, if you have a sidecar and a packet has to go out to, say, app 1 is talking to app 2, the packet has to go out. It has to actually traverse the whole path of your network stack. It has to go through sockets, it goes to physical network, and there you have a loopback address. Again it travels back to your sidecar, and then from sidecar again it traverses back into the physical network. So it's a whole big journey it takes. This again repeats itself in the destination pod, right? So you have 2 extra hops and that much travel, so which obviously impacts your performance and latency. If you are, even though there are solutions which, like Linkerd, which promises that the latency that it adds is very, very minimal, but if you have an application which has more need of a high requirement of less latency, this actually counts a lot, right? These are the 2 basic or fundamental challenges that we see with the sidecar model. But until now, until say recently, this is the only way that we saw in market people were solving the problem, right? Enter eBPF. So eBPF is a as a technology, I think Bharini has introduced it, so I will not repeat what he said. So just a couple of lines. So eBPF is a way to extend your kernel without reloading the kernel or rebuilding your kernel every time. You can hook in your code to all the syscalls. So when I say hook in your code, and what is syscall? Syscall can be as simple as storing a variable in your hash, or reading a file, opening a file. Everything that you're doing with your underlying OS is a syscall. And eBPF gives you a way to hook in your own code in any of these events. It's basically event driven, so you can say run this code when this event happens, as simple as that. Now eBPF itself you can only write, or the kernel code itself you can only write in a CLang compatible language, which is again C++ or now Rust. So again you get into the problem of, oh, I have to code it. Actually no. So this is like eBPF is a platform where people are building solutions. There are already a lot of solutions that are built, or a lot of problems that were solved using eBPF, and you can use those solutions directly without you coding yourself, right? It's like what Google is to your browser, right? You don't know how, you don't need to have to have knowledge of how to build a website to use Google. So right, so the one solution that came up with using eBPF to solve this problem is Cilium, which basically uses the eBPF to implement CNI, which is Container Network Interface for Kubernetes. So their initial problem statement was to solve the network network topology or network latency problems using eBPF. But what they saw was they are already delivering stuff that a service mesh does by implementing the CNI. They already had observability, they already had rate limiting, they were doing all the stuff in kernel. What do you mean by in kernel? So as we all know, containers, however they are running, they are all in a single machine, they are all sharing the same kernel, right? So if I am loading some code into my kernel, essentially that can be shared across all containers. So rather than having one sidecar per container, you can simply load your code into kernel, and that code basically applies to all kernels, that all the containers that are running on the kernel, right? The simple thing that they thought, okay, we are already doing this, why not just extend it to add the missing features that people are using out of service mesh, right? So just go forward a bit. So this is what we had before service mesh came into picture. We had everything inside app. Then smart people came and said, okay, let's remove the redundancy, let's move that out and put a proxy in front. Now even smarter people, now they are saying, let's not even have the sidecar, let's move everything to kernel, right? We do say that service mesh actually abstracts things out. Developers don't know or they wouldn't care about what is happening there, but if you think about it, if you go and see a pod, you will still see a sidecar. You still see something there additional than what you are deploying. It's not truly transparent. But if you go with this model, when everything is kernel, you wouldn't even know there's something is extra deployed. It's basically transparently working, right? So just go back again. Sorry. Okay. So as I said, by default, there were several things that was implemented by, the features that were there for service mesh were already implemented by Cilium. So the missing piece was how to do a level 7, how to add a level 7 capability. That is, say if you are, most of the service mesh users use service mesh to gather level 7 stats. For example, how many requests are coming for this particular endpoint, or you can have say what is the what is the traffic, say given a pod A, pod B, how many times pod A is calling pod B, this particular pod. So there are those needs which can't be solved by a kernel program which essentially works on a level 3 or a level 4 layer on a network layer, right? The eBPF is still not advanced enough due to its restrictions. Obviously you have that verifier which basically blocks you if you want to write any fancy code. So we are not still there where you can have a level 7 capability put into kernel code. So now what they did, okay boss, if you have something that for some requirement, if you need a level 7 capability, just pass it to a proxy. Proxy is still needed, but it won't be one per application, you put it one per node. So you will have one proxy that would be running in your whole worker node, and any level 7 capability that you would need, the traffic would pass through that proxy. If you don't need any level 7 capability, for example, you don't need mTLS, for example, that's one of the L7 capabilities. You don't even need to have the proxy, don't even need to pass through the proxy pass through the traffic to the proxy. Right, so this is one of the features that are going to add. Actually, this has come up, and this would be released in the next release, where they are basically implementing mTLS, which is a missing feature, one of the missing features. So what they are saying is, we will give you a way, we will separate out the concerns of encryption and authentication. We will use a certificate management tool like a SPIFFE for authenticating two services, saying okay, service A, when service A is talking to service B, it is actually service A which is talking to service B. Both can authenticate each other. That's basically mTLS. And then encryption, they are saying we will make it optional, and it will happen using IPsec. It won't be a like other service mesh implementations doing, where they have to have a certificate rotation policy and a lot of complex stuff that they do to enable mTLS. So this is again an interesting space that you can watch out how they are implementing mTLS in Cilium. Yeah, so these are some stats that we have taken from Isovalent, which is the parent company of, Cilium was open source and still open source, but Isovalent is formed by the co-founders or the creators of Cilium. They have several projects under it, and one of them is Cilium. You have Hubble and others. So they did a comparison on with existing sidecar model and with the eBPF model. The first one that you see is the latency when you don't want, I mean, 3 cases with Cilium and with sidecar. The first 2 is basically with Cilium, but if say you don't want observability, a level 7 observability, then the blue one is the graph you see where your latency is little less. If you want to have observability on top of whatever you're doing, then it increases a bit, latency increases a bit. And the yellow one is a sidecar model, and you can see the latency is almost dropped by more than 100%, right? And the second one, the second graph of it is related to the mTLS that I was talking about. The blue one is Cilium without encryption. As I said, encryption itself was optional. Again, this is also latency, 95 percentile. And the Cilium with encryption, and the last one is Istio or Linkerd, whatever you can basically put any sidecar model there. So here also we could see a lot of latency decrease.
Okay. So on the closing note, maybe I'll do as a summary of whatever we saw so far. It has actually, from the inception, it has come in a long way, right? And still we are facing a lot of problems. For example, how do I switch service mesh implementation, right? I don't want to use Istio, I want to go with Linkerd, or if I want to go with something else, what is the way out, right? That has been kind of evolving. I'll not say it's 100% completely done. The reason why it is, I'll not say it's service mesh interface is not a silver bullet which will solve your problem. Hey, I'll choose Istio, tomorrow I'll choose Linkerd, right? It is not that. I'll tell you, right, because let's say a newer version of Istio comes up. This service mesh interface has to be catch up to that. If they release a newer version of it, then this also has to evolve, this also has to support. And this also has to be supported by other service mesh interfaces, so that this interface will be a common, right? And a few whatever, even though this says an interface, you can, other service mesh implementation can choose to not implement that particular feature alone, correct? So what could end up happen today if we go for this, right? For specific use case, let's say if you are choosing Istio or something like that today, you will end up choosing or writing little more of Istio's feature, which is still not there in service mesh, because these will not even caught up to that particular level, or they need to keep on updating themselves, because if they're going to support all the service mesh, whenever there's a new feature, they need to do a compatibility to that as well, right? So it is evolving, but let's say, but it's a good start. So all these 3 use cases, whatever we showed earlier, right? If that is a thing, then you can actually start using service mesh right away, right? And on the multi-cluster, this is very, very also interesting space, right? All the organization actually started growing, right? And every team is actually looking for, hey, can I grow independently? Can I deploy to my cluster alone? Can I do that, right? So currently, if you do want to do that, then you will end up creating multiple clusters, small clusters for team, and then you can give an autonomous to the team saying, you go ahead and deploy it at any point in time, right? But that brings in a complexity where, how do I do this cross-cluster communication, right? How do I do it? All those things, you don't have to worry about it, leave it to the service mesh. I think every player is actually doing a very good thing in this multi-cluster thing, right? Istio supports this, Linkerd supports it, Cilium supports it. Everybody does a good support on multi-cluster, right? Absolutely. So you can, if you don't have to worry about anymore saying how do I route the traffic from one cluster to other cluster. So you can leave it to service mesh. It can do it for you. That's the stage it is in, right? And on the WebAssembly part, this is also very promising, where you can write all your common filter logic or whatever you wanted. You can write it in a WebAssembly, and then you can put it. And currently, only Istio kinds of supports this WebAssembly model. I don't know whether other has caught up, because Linkerd uses its own Rust-based proxy server which runs it. I don't know whether that can actually also hook up to the WebAssembly and can actually also add as a VM, run it, all those things. We don't know, right? But as of now, Istio supports it. But this also has a long way to go for, right? But one thing which is really, really promising is this eBPF, right? And because before this, we didn't have any clue of how do we get away from this L3, L4, L7 because we are stuck in that particular world, and there is no technology or something which existed so that we can actually not to think in that lines, we can think in new lines. That doesn't existed. Whatever you have to do it in the user space, and all, whatever you want to read a file, or if you want to read anything from the system, you have to cross the boundary. You need to go to the kernel space, make a syscall, come back and then do it. So think of all these use cases. Right now we had 1 Gbps line, will we end up getting 10 Gbps line, or will be getting 100 Gbps line, whatever be it, right? The moment you get more and more speed, right, for every call you make from user space to the kernel space, come back, that will be much higher than your packet transfer rate itself, right? Then how will you catch up with that particular thing, right? So all those things kind of evolved and solved by eBPF. eBPF has actually another thing for network which is called Express Data Path, XDP, right? Which actually interacts directly with the network interface, and it doesn't even come to kernel at all. So you can write a proper filter in the network interface itself, and then you can actually get away with whatever you don't want it or want to route it from there, right? Take it from network interface and directly route it to the namespace. Think about it, all those features you will get it, right? And this is revolutionary. And why we are talking about eBPF now, and maybe I recollect some of the thing what Barney said, right? So this particular feature has been there in the Linux kernel, introduced 4 years back itself, and it has adapted now, and it has been rolled out by all the distros, and it is in mainstream. So if you are using latest version of Linux kernel, high chance it will be here, it will be there. And that's the reason why it's picking up recently, and then everybody is going on this, crazy on this. Okay.
Yeah, so I guess we just want to part ways with you with saying goodbye Sidecar. I know it might be too early, but we do see that this happening, and do see this happening soon enough, right? So we do see that once the service mesh offering from eBPF world matures, you should be able to do everything that you're doing with sidecars now, and there wouldn't be any reason to have the sidecars and spend so much resources on them. That's about it, I guess. We can. Thank you.